actually have to have practice writing out in binary. Anytime I convert anything into binary, I always have to think about having these placement values. Now, it's easy to see what a 0 looks like, right? 0, 0, 0, 0. Well, if you have a 1, that's 0, 0, 0, 1. If you have a 2, notice here, the 2-bit has to be turned on. Everything else will be zeros, okay? And then 3, 1, 1, okay? Anytime you see all 1s on the right-hand side, your next integer, these ones turn to zeros, and then you go up your next placement value, okay? 5 looks like a 4 plus 1, okay? And a 6 looks like a 4 plus 2. 7 looks like a 1, 1, 1. Again, all 1s, the next integer is going to say 0, 0, 0. Increase that next integer by 8, okay? So on and so forth. But always think about it like this again, and this is exactly what we were doing just barely, except they're just not drawing all the zeros on the left-hand side. But again, always think about these integers whenever we're dealing with it. You can get any number you want from, 1 to a million if you wanted to really do it, okay? The powers of 2 are very important. Again, it's good to know these placement values. And again, the numbers that you guys wrote on the top of your page, that's exactly what you get. 1, 2, 4, 8, 16, 32, 64, 128. Okay? But always know powers of 2 up to the powers of 10, especially when we start doing 2 to the h minus 2. Sometimes you guys are going to have to work with 2 to the 12 without doing it on a calculator. So you're going to need to know these numbers. As far as the decimal and binary charts go, again, they're going to give you an example here about 63,204,829. How do we get this in dotted decimal? Again, we know that, in the 10 to the 7 spot, that's in the 10 million spot, million, 100,000, 10,000, 1,000 spot, 100, 10, and 1. If you give a value of 6 in the 10 million spot, that gives you 60 million. Plus 3 in the million spot, that gives you 63 million. Plus 2 in the 200,000 in the 100,000 spot gives you 200,000. So on and so forth. Eventually, when you add all those numbers together, you get the same number as you get up here. Okay? Binary is no different than this. The only difference is your placement values are different. Instead of the 10 millionth, million, 100,000, you're going to get 128, 64, 32, 16, 8, 4, 2, and 1. Okay? So there's always going to be a pattern here with IP7. It's always going to be a pattern of powers of 2. Again, you're not dealing with complex numbers like 1 through 9 and 0 and whatnot. You only deal with 1 and 0. 1 means count it, 0 means don't count it. So in the event that I'm counting 128 plus 64, that's 192. Plus 32 is 224. Plus 8 equals 232. Plus 1 equals 233. Okay, just add it up.